Good day everyone! Today, we're going to explain how indeterminates can be solved. This video will explain indeterminate form of 0 multiplied by infinity, solve for the sample equations, clarify the indeterminate form of infinity minus infinity, and calculate for sample equations. For the indeterminate form of 0 multiplied by infinity, if f of x approaches 0 and g of x approaches infinity as x approaches a or x approaches positive or negative infinity, the product f of a multiplied by g of a is undefined and is said to assume the indeterminate form of 0 multiplied by infinity. If the limit of f of x multiplied by g of x exists as x approaches a, it may be found by writing the product as a fraction. F of x over 1 over g of x, or g of x over 1 over f of x, and applying L'Hopital's rule. To further understand the indeterminate form of 0 multiplied by infinity, here are some examples.
First example. The given is the limit of sine 3x cotangent 2x as x approaches 0. First, you will have to substitute x to the given. So f of 0 will be equal to sine 3 0 cotangent 2 0. F of 0 will be equal to 0 times infinity. To solve this kind of indeterminate form, you will need to express the given as a fraction. Since cotangent 2x is also equal to 1 over tangent 2x, you can express this as the limit of sine 3x over tangent 2x as x approaches 0. Again, substitute x. F of 0 is equal to sine 3 0 over tangent 2 0. F of 0 will now become 0 over 0, which is also an indeterminate form. This kind of indeterminate form can be solved using L'Hopital's rule. In applying L'Hopital's rule, you will have to get the derivative of the numerator and the denominator. The derivative for sine is cosine u du, so the numerator will become 3 cosine 3x. The derivative of tangent is secant squared u du, so the denominator will be equal to 2 secant squared 2x. Finally, substitute x and it will become f prime of 0 equals 3 cosine 3 0 over 2 secant squared 2 0. Equals 3 times 1 over 2 times 1. The final answer is now 3/2. Example number 2. The limit of secant 5x cosine 3x as x approaches 5 over 2. Just like in the first example, substitute x. So f of pi over 2 is equal to secant 5 pi over 2 cosine 3 pi over 2. F of pi over 2 will now become infinity times 0. Again, express it as a fraction. Since secant 5x is also equal to 1 over cosine 5x, you can change the given to the limit of cosine 3x over cosine 5x as x approaches pi over 2. Substitute x. F of pi over 2 is equal to 3 pi over 2 over cosine 5 pi over 2. The result will become to 0 over 0, which is again an indeterminate form. Solve using L'Hopital's rule. The derivative of cosine is negative sine u du, so the numerator will become 3 sine 3x as well as the denominator will be equal to 5 sine 5x. The sign will be cancelled since both the numerator and denominator is negative. Substitute x. So f prime of pi over 2 is equal to 3 sine 3 pi over 2 over 5 sine 5 pi over 2 equals 3 times negative 1 over 5 times negative 1. The final result is negative 3 over 5.
For the indeterminate form of infinity minus infinity, if f of x and g of x both increase without limits as x approaches a or x approaches positive or negative infinity, the difference f of a minus g of a is undefined and is said to assume the indeterminate form infinity minus infinity. if the limit of f of x subtracted by g of x exists as x approaches a, fraction by algebraic means, and applying L'Hopital's rule. For this kind of indeterminate form, here are some examples.
Sample number 1. The limit of cosecant x minus cotangent x as x approaches 0. Substituting x will have f of 0 is equal to cosecant 0 minus cotangent 0. F of 0 will become infinity minus infinity. In solving this kind of indeterminate form, first transform the difference into a fraction by algebraic means. Since cosecant x is equal to 1 over sine x and cotangent x is equal to cosine x over sine x, you can change the given to 1 minus cosine x over sine x. Substitute x. So f of 0 is equal to 1 minus cosine 0 over sine 0. The result is 0 over 0 and is still an indeterminate form. So you will have to use L'Hopital's rule again. Since 1 is a constant, its derivative will be 0. The derivative of negative cosine x is negative sine x. And the derivative of sine x is cosine x. Substitute x. So f prime of 0 is equal to sine 0 over cosine 0, which will result to 0 over 1 or 0. For example number 2, the given is limit of x over ln x minus 1 over x ln x as x approaches 1. Substitute x to have a result of f of 1 equals to 1 over ln 1 minus 1 over 1 ln 1, which will result to an indeterminate form of infinity minus infinity. Again, change the difference into one fraction by algebraic means. Since the given is both fraction, you will need to get the LCD, which is x ln x. The given will now be limit of x squared minus 1 over x ln x as x approaches 1. Substitute x to have f of 1 equals 1 squared minus 1 over 1 ln 1. So f of 1 will be 1 minus 1 over 0 equals 0 over 0, which is still an indeterminate. Applying L'Hopital's rule, we'll have f prime of x is equal to 2x over 1 plus ln x. Substituting 1 will result in 2 over 1 or 2.
And there you go! Hope you learned a lot from this tutorial. Thank you for listening and God bless!